Hello everyone, I'm Stephanie Skipp and I'm a PhD student from the University of East London. Today I'm going to be talking to you a bit about some of the insects that live inside decaying wood. Now you've probably heard of some of these because the mighty stag beetle uses decaying wood to allow its larvae to develop into adults. But did you know that there are over 1,700 species of decaying wood specialist invertebrate just in the UK? Many of these are uncommon and some of them are even endangered. So in this time that humans are having a massive impact on all sorts of invertebrates, it's really important that we put lots of effort into making sure that these populations of decaying wood invertebrates persist into the future. And my PhD looks a bit at some different ways that we might be able to do that. So just before we start, let's talk about some of the different types of decaying wood invertebrate you can get. Lots of these have different strategies. So for example, some species live inside their decaying wood habitat for their entire lives. Other ones just take advantage of the protection that the wood gives them while they're in their fragile development stage. So on the right of your screen, you can see a click beetle pupae that was all tucked away nice and safe underneath some bark before we rudely disturbed it. And on all of these invertebrates, you get predators and parasitoids that specialise on attacking them. So you get a really rich ecosystem of all sorts of interactions going on, all inside, hidden away inside a tree. So yeah, it's really amazing. But you might think, why should we bother trying to conserve these? Well, they do actually provide some really good processes for us that help a lot. So some of them are involved in nutrient cycling. So nutrients get locked away inside a tree, and as it begins to decay, the invertebrates have a role in returning those nutrients into the soil, which promotes the health of a forest into the future. Those predators and parasites that I mentioned earlier, they can attack certain species that without those predators and parasites might otherwise expand massively in numbers and become a pest that could damage the forest. So they help to prevent that. And something that you might not expect, a number of pollinators also use decaying wood. So you might be excused for thinking the picture on your screen is a bumblebee, but it's actually a fly, quite a rare fly, the Bleraphalax. There are also bees that use decaying wood, so it's really important that we protect this habitat. An overarching term for decaying wood invertebrates is the word saproxylic, so I might be using that throughout the rest of this talk. So here you can see a number of really lovely saproxylic habitats. You can see some peeling bark on this tree, and you do get some specialised invertebrates that are really flat so that they can fit into the tiny crevices underneath bark, and they spend their lives in there. You get some saprons, which provide some lovely nutrients for many types of invertebrate. And the most obvious feature you can see on this tree is the really big hollow there. Now, hollows are great. Inside of them, you get this substance called wood mold, which is really nutritious and a safe place for lots of invertebrates to spend their lives. When you get these hollows inside living trees, they can persist for hundreds of years. So that makes it even better of a habitat. But the long-livedness of the habitat means that lots of the invertebrates that live inside of them don't adapt to be very good dispersers, because after all, if your habitat's going to be there for hundreds of years, why should you bother thinking about moving? But the fact that these invertebrates are often not the best dispersers is a bit negatively impacting them at the moment, because our woodlands are under threat. In a study published in 2001 by the Woodland Trust, I think, they found that 38% of the UK's ancient woodland with these lovely ancient trees have been cut down and replaced with less diverse plantation forests. So that would be lots of young trees that don't have these saproxylic habitats. Also within the woodlands that we do have, lots of the trees have been cut down and harvested for their wood, and that was especially the case during wartime, where the wood was needed for naval ships. So the fact that we are starting to deplete our forests means that in the future there might not be enough habitat for our invertebrates. And invertebrates that do persist inside a tree might be at risk of becoming isolated. Now I'm going to talk a little bit more about why an isolated population is a really fragile population over the next few slides. So here's my lovely clip art that I've made for you. You can see here a little rhino beetle living inside its lovely ancient tree. But should something happen to this tree that would make it the habitat unusable, it's important that there are a lot of other ancient trees within the immediate vicinity so that our little rhino beetle can escape and the populations can continue to flourish. But in a poorly connected habitat, should something bad happen to the place that rhino beetle lives, it might not be able to escape and the population could die out because of that. So it's really important that we have well-connected habitats, especially as these invertebrates aren't very good at dispersing very far. So part of my PhD is looking into how well connected we need our forests to be in order to best support our invertebrates. So I went to some lovely National Trust sites and I put some traps into the trees. You can see this trap here. It's called a cross-vein flight interception trap, and it's called that because as the beetles and insects are flying around, they'll bash into that flight interception trap and fall into the funnel and then get collected in the bottom. And I'm looking at the distribution of the species across trees that are differently spaced from each other. And I'm trying to look into what's the optimal amount of spacing between the trees that best supports these invertebrates. This information could be really useful for landowners, especially ones that are planting new forests. So we could tell them the cut-off distance that we really need the trees to be within each other so that we can breed the best forests for our future invertebrates. But should you find that your forest may be lacking in habitat and may be falling below these thresholds of connectivity, there are ways that you can get around that. So there's something called veteranization. It might look like the picture on your left. This guy is causing massive damage to this tree and you might think, oh, he's killing the tree. But actually what he's doing is mimicking the natural process that happens when a tree gets struck by lightning. It causes this massive linear fissure down a tree. And that opening is an opportunity for fungi and bacteria to enter a tree and start to cause that decay that creates the habitat. Using these veteranization processes, you can get decay-related habitats in much younger trees than you might get as it naturally occurs as they slowly grow older. And when you get decay-related habitats in a young tree, you call it a veteran tree. Now, this tree on the right has quite a small girth, so it's quite a small tree, quite a young tree, but it has throughout its life undergone some damage and that's introduced some decay into it. So it is a good habitat for these invertebrates. But this process does take a bit of time so that as the hollows and things develop. So my PhD is also looking into a more short-term, quicker solution to do it before, as part of this process. So while we're waiting for these veteranization trees to fully mature. And that gets me to the main topic of my PhD, the beetle box. So you can see one here on the right. It's a lovely construction. What it is doing is trying to mimic the habitat of a basal hollow in a tree. So this other picture on the left is a basal hollow. And inside there's quite a unique habitat where soil meets wood mold. And that is a particular habitat that is preferred by the violet click beetle. And that is an endangered species in the UK where it's only found in 2 and maybe 3 sites across the whole of the country. So we've put our beetle boxes into these sites and we filled them up with some ingredients that we think will rot down to create some lovely ideal wood mold for this species. So we've put in there some soil, some sawdust, some leaf litter, and we've even put in a bit of bird manure because inside of natural tree hollows you'll get birds nesting, and it's thought that the nutrients in their poo is a really important factor that helps to support the populations of invertebrates that live inside of there. So over the coming months, we're going to be doing our first round of sampling from these to see what invertebrates have colonised them and to see if they're performing as well as a real tree. But one of the problems that we foresee in the future is that, as I said before, the hollows in real life trees can persist for hundreds of years. But looking at our box, it probably isn't going to be around for that long because it's not made out of live wood, it's made out of dead wood. So we've come up with a few solutions that we're also trialling alongside these wooden boxes. We've got a plastic box, which is, yes, it's a wheelie bin that we've buried, and this wonderful bespoke concrete box that we enlisted the very talented architectural students at the University of East London to create for us. Both of these will last a bit longer than the wooden boxes, but we're trialling to see just if they would perform as well as the wooden boxes. So we're looking forward to getting those results, and I hope you'll look out for my results in the future. So thank you very much for listening to my talk. I'd like to thank my supervisors from the University of East London, as well as my funders, BugLife and Natural England, and also the Crown Estate for giving me permissions to visit their sites, and the National Trust for all the really helpful assistance that I got from the volunteers there. Thank you very much for listening, and I look forward to hearing your questions.
Fantastic. Thank you so much, Stephanie. Has anyone got any questions that they would like to ask? Anyone want to give a shout out on the group chat? So
I can start it off if that's okay.
Go ahead.
So fantastic talk. Thank you very much, Steph. I was just wondering if you'd have any advice for anyone, or whether you think it would be worthwhile at all, in fact, to create little beetle boxes in people's gardens.
We have actually had quite a lot of interest of this when we've been going to events and things and bringing along a mini beetle box. Everyone's like, oh, I want to build one in our garden. Unfortunately, we don't have our results yet, so we don't fully know exactly how effective it will be. But it is always a really good idea to introduce a bit of deadwood into your garden, especially if you live somewhere near a woodland. So you could try a beetle box and do your own experiments at home, or you could do something that helps stag beetles and a number of other beetles by just finding a bit of deadwood and potentially part burying it into the ground. That's another thing that creates a good habitat. But yeah, just if you need to cut down a tree, maybe leaving a piece of that tree in your garden just to slowly rot, and you can enjoy all of the invertebrates that come there by doing your own little investigations and rolling it over and peeling a little piece of bark off. It's really interesting to investigate those communities.
Great. I was literally going to ask exactly the same question, Jordan. I've even written it down: beetle boxes in gardens? Question mark. Question mark.
Do it. That's Beetle City.
Why not? Why not? Has anyone else got any more questions? Because I've got one. Just before anyone jumps in, what I was going to ask, thinking about is how, like, in terms of like science communication and that kind of like public engagement thing regarding beetles and bugs and invertebrates, what are the public like? What are people like when you try and kind of like get them engaged in it? Because it's not the quite a lot of people are a little bit squeamish about it. Maybe I know people obviously like Jordan love that kind of thing, but like how can you get people into caring more about invertebrates? Obviously they're really important for ecodiversity, so how can we get them to be more interested?
To be honest, I've had mostly positive reactions when I've been talking to people about my my project, which is really good. I don't know if I've just been going to places where people are a bit bug friendly, like science conventions and things like that. But I think the more you know about something, the more accepting you are of it. So just trying to promote sort of education and getting people to just keep an eye out for different insects in their garden, because if all you know is like a black and white stripy wasp that's trying to attack your picnic, you might be a bit, I don't know. But also among some people who work in the trade, they have the impression that because all they hear about is pests, they think, oh, all bugs are an enemy of our woodland. Whereas actually the more bugs that you have, the more control they're doing of those pests by themselves. So it's actually better to have more bugs that are doing that job for you. So yeah, I think just general education and making sure people are getting all the sides of the story, the really cool, interesting ones, as well as maybe some of the scary ones.
So I've got another question from Sean. He said, great talk. I was wondering about pest beetles. Would the knowledge gained from the tree distancing be useful for distancing at-risk trees?
I haven't, to be honest, I haven't thought about that much. I think the main places where pest beetles become an issue are those sort of plantation woodlands where they don't have all the massive community of predators and things coming to attack them. and that is often a place where they're really closely spaced as well. I'm not sure if a plantation woodland you would be able to distance the trees, because then you would have less trees, and I think the idea of a plantation woodland is that you squeeze as many trees in as possible because you're harvesting them. So I'm not sure, to be honest, is my honest answer, but that is a really interesting point that is potentially something good to consider.